Yeah. You're so cute. You guys are nice. Yeah. Oh, she said, we need to start there. I said, now I put both on hold when I met. Yes, they can definitely help you.
All right, young scholars, this week we are going to be covering abstract classes and interfaces. You saw when we talked about inheritance that abstract classes and interfaces are commonly used with respect to those. So an abstract class is used to provide common method implementation to all of these subclasses or to provide a default implementation. Hence, it's used in inheritance, as you saw last week. So here's an example. Abstract class, geometric object. It can be passed to a circle. It can be passed to a rectangle, triangle, whatever specific geometric object you can think of. In this example, we give just circle and rectangle. So we're able to use get area, set color, fill, etc. for any type of geometric object. So an abstract method can be contained in a non-abstract class. In other words, if you just have a regular class, you can have an abstract method within it. It doesn't necessarily have to be static. If a subclass of an abstract superclass does not implement all the abstract methods, the subclass must be defined abstract. In other words, if you have a non-abstract subclass, you have to extend from the abstract class. And we saw that last week. So objects cannot be created or initiated using a new operator, but you can define it using constructors. That's why we use that extend, or for an interface, we use implements so that we're able to pass all of these specific parameters and methods from the superclass down to the subclass. So any class that contains abstract methods has to be abstract itself. Can't be public, static, etc. It is possible, however, to define an abstract class that contains no abstract methods. Like I mentioned, the most common reason you would want to use an abstract class is when you're using inheritance. You're going to extend whatever methods or variables that class automatically creates. Take from the superclass, bring it down to the subclass. So a subclass can be abstract even if its superclass isn't. The object class doesn't have to be abstract, but the geometric object class may be abstract. So you may want to extend the geometric object to the circle, to the rectangle, to the triangle, The reason that matters is because you have the opportunity to override methods. We saw that last week with inheritance, right?
Yeah.
At override, and you're able to override a method within the subclass. So then it works based on what you need it to do, as opposed to the way that it was defined in the superclass.
So you're gonna come up to the reference numbers.
So an abstract class as a type, we also saw this last week. We did the circle equals new circle. It basically serves as a workaround to the fact that abstract classes are not allowed to create new objects. So you use the class as a type. So like we saw last week, new circle, new keyboard, I think it was, or new piano. You create a type or instance object using the class in order to work around the fact that you cannot create an instance from an abstract class. So that super abstract class, you can't create an object with it. So you extend it to a subclass and then create the object within the subclass based on your needs. So here's an example. You would have the superclass number. All of these are specific subclasses. Double, float, long, integer, short, byte, big integer, big decimal. All of these are types of numbers, but they're not all the same. So the number is the superclass, and each of these individually would be subclasses. So you could use a float that extends number and create an instance where you have a new float, just like you did last week with inheritance, with new circles, new rectangles, etc. You could create a new instance of an integer, a new instance of a byte. So we used the superclass calendar early in the semester, but it has a subclass Gregorian calendar based on how long it takes the sun to rotate around the earth. So that's why we have 365 and a quarter days in a year. And that's why every 4 years we have the leap year. So we would be able to inherit or extend our calendar superclass into our Gregorian calendar subclass. So we'd be able to find the time. We'd be able to set the time, set the day, get the time, display it. Every time we run a program that would say get time, it will display out what that exact time is to the second. So as you saw when we did it earlier, it's more common to use just the calendar superclass itself, because then we could just use the date subclass, which will basically do the same thing. It will provide the same answer with you, and obviously it's a little easier to import util.date or util.calendar as opposed to spelling out the full Gregorian calendar. But when you're going to do that, you're going to set it up similar to how you would set an index in an array. So your Gregorian calendar, it understands that there's 12 months in a year, but it starts at 0. So January is 0, December is 11. So it's similar to how an index array is set up, where it's 0 through 1 less than however many elements you have. So in this example, we have 12 elements, 12 months in a year. So it's 0 through 11 instead of 1 through 12.
Yeah.
So we could either use a new instance of Gregorian calendar and set 2023, October 10th. Or we could use the simpler way with the calendar class, as you saw earlier this semester, where it would just display everything for you. We could use the get method in order to either get or find, or obviously we could use the scanner class to get input from the user to tell us what the day is, the year. But using that get method, it's more accurate. So if we were to ask the user, what is today? They may answer Tuesday. They may answer October 10th. They may answer 2:24 p.m. They may answer, the third day of the week, the second day of the week. Their answer may vary. Whereas if you use the get method to get the date, it's just going to display the date, today's date. If you ask for the month, it'll just say October. Whereas if you ask for a user's input or a user's answer, their answer may vary. That's why we touched on exceptions last week. If you ask a user what is today, and they tell you Tuesday, you might have an input mismatch. You may be expecting the number 10. You may have set it up as an integer. And if they enter Tuesday, because it's Tuesday, there's an input mismatch. There's an error because they entered a string when you were expecting an integer. So we also touched on interfaces last week with inheritance. These are the ones that instead of extend the superclass, they implement the superclass. So you want to use an interface in cases where you don't necessarily need to outright copy. When you're using an abstract class, that's basically when you're outright copying everything. As you saw last week, interfaces are also heavily used with inheritance. It's a class-like construct that only contains constants and abstract methods. That's why instead of extend, or taking everything, we just implement instead. We're basically just taking what we need. So basically an abstract is you want to take everything, interface, you're just implementing it. If I need it, I'll use it, but I might not use everything. Whereas an abstract, you're probably going to use everything, and you might even have to override it to use it the way you would like to use it. So here's an example. Public interface edible. Describe how to eat. Public abstract string, how to eat. You'll notice there's no constants. In this line, we have constant declarations, but in our example, we don't necessarily have them. But we do have a method we've created. This how to eat, and we know it's going to be a string. That's like you'll see, or you saw last week with our examples. Like for the instruments, I believe it was, we used the method play, or the animal example. You know, the cat meows, the dog barks or woofs. And you're able to use that method you create within other subclasses. So you might have, with public interface edible, you might have chocolate extends edible. And then you would run your method. This is how we eat chocolate. You know, we put it up with s'mores on graham crackers and marshmallows, as an example. So as you saw last week with abstract classes, objects are harder to make. Just like an interface, there's that workaround that you would use, where you're going to use the class in order to create your object. So just like you saw with the fruit and instrument examples for inheritance and polymorphism last week, we have here our class edible. The interface, we dropped down to fruit, chicken, tiger. But chicken and tiger can also extend an animal abstract class, because they also fit in that criteria. And then, as you saw last week, orange and apple can extend fruit. An orange and an apple is a fruit. So if you had that interface edible and passed that method, how to eat, obviously you would eat fruit and chicken in different ways, right? Fruit you might be able to eat with your hands. Chicken, you might need a fork. You might put barbecue sauce on it. Different variable possibilities. So you can also omit modifiers in your interface. So in this example, we've created the same exact interface. Instead of setting integer k1 as public static final, we just can write integer k equals 1. We know it's final. Instead of writing public abstract void p, we know that method is going to be abstract. They're equivalent. They work the same way. You don't necessarily need to add that, because they will be set as equivalent. So if you have an interface name, let's say it's fruit, dot, let's say it's apple, you can find an instance of it, similar to retrieving an index in an array. So here's an example of that. In this example, we're defining the package java.lang. We're creating an interface comparable. Anytime you see this, less than E, greater than, we know we're creating a simple array list. So our method is now public int compare to EO. We're now comparing all of those objects to see if any of them are integers. So 0 might be, the index 0 might have an integer. The index 1 might have a string. The index 2 might have a Boolean. We compare them. We only find our integers, what we're looking for. So we've seen previously how to use the toString method and the equals method to compare. Compare to is similar. So we use the toString method in order to pass something to a string. We did that with the array list earlier. Compare to checks to see if they're not necessarily equal to one another, but that they're the same type. So a string has to equal a string. An integer has to equal an integer. A Boolean has to equal a Boolean. Just like you saw last week with the exception handling. If you don't have the right input, there's going to be an issue. If we're looking for a string, we need to input a string. So there are classes, sub, and super that also relate to data types. So integer in this instance would be your superclass. Then you could have big integer as your subclass. So you might want to use a big integer when you have a very big number, 85 million as an example. Similarly, string would be a superclass and date would be a subclass in this example. Your date might include integers, 2023, 1010 as an example. However, it might also be or include all types of characters. So it'd have to be labeled as a string. October 10th, 2003, 2023. So you would have the month is a string. 10 is an integer, but there's a TH after it, 10th. Then there'd be a comma. Then there would be 2023. So you'd put that whole date together within the string. So you might want to use what is called the sort method. Obviously, as I mentioned, similar types are comparable. So you have n instance of integer. You can compare that to none of the others, right? N instance of object can be compared to S instance of object and D instance of object. They're all objects. We can compare them. They're the same. N instance of integer, S instance of string, D instance of java.util.date, they're all different. We can technically compare all of these. However, the only instance where they'll be able to be comparable is once we've created an instance of the object. We can utilize the java.util.arrays.sort with our array method, which would sort all of the different instances within an array list. If they're not the same, let's say we have 3 integers 3 strings, and 1 date instance. It's going to sort the 3 integers together. It's going to sort the 3 strings together. And depending on how it was set up, the date may be at the top of the list, the date may be at the bottom of the list. That is why you want to have comparable types. So you might have all integers within your array list. It should be sorted from top to bottom, lowest to highest. And we'll see that much later on in the semester when we cover sorting, when we touch on bubble sorts and all our different specific possibilities. So I mentioned that you can technically clone interfaces. That is because there is what's called the clonable interface. You're basically mimicking another class. For those of you that know about Pokemon, think of the Pokemon Ditto that just transforms into whatever it sees. So in this instance, we might have a marker interface that has nothing in it. No constants, no methods. It's completely empty. We then use the clonable interface in order to clone anything within as we need. The clone method is defined in the object class. So again, this is another way we can use to work around the fact that we cannot create classes within abstract or interfaces. So we're using clonable in this instance to create a new instance of a calendar. So we're using calendar.clone in order to create a copy, a clone. Then we print out our new calendar. This equals that you've seen previously is similar to what we touched on with comparable. We're making sure that our types match, they're comparable, they equal. So in this instance, we're setting a new calendar to now be February 1st, 2003. We create a copy using the clone method. We then do calendar, our first object we created here. We compare it to calendar copy is, and then display it. If they are not comparable, it displays a false. If they are equal, they are comparable, it'll be true. They'll be a display. So again, that is another type of workaround to the fact that we cannot create objects in classes or interfaces. We clone them. We create copies of them. So we create an object calendar. We then clone it, make a copy of it. So there's different types of copying you can do, called shallow and deep copy. So in this instance, we're creating what's called a shallow copy. We're creating an object house 1 with an ID set as 1 and an area set as 1750.50. We're then creating a second object that simply clones that first object, copies it. You'll notice house 1 and house 2, exactly the same ID, exactly the same area. But what happens with a shallow copy is that it stores the references of objects to the original memory. So you'll notice here, when built reference, and the date object contents. So both references from your initial and your clone go to the same place. They're in the same memory reference. But then with a deep copy, you'll notice instead of one reference, they each have a different reference point. But the deep copy stores copies of the object's value. So you notice date object contents, one instance with shallow, each has their own instance with deep. Now, when you have a deep copy, however, you're obviously going to take up more of your computer's resources. You have two separate pieces of data being stored. So what would be the object's value here? Would it be the ID or the area? It should be the area. Even though it's the same, it's what we need to pass. We don't necessarily need to worry about the ID. But that area is important. We need to know that when we're building the house. If we build it too big, we got to pay more. If we build it too small, the person who wants to buy the house may not buy it. It's too small. So here is an easy way of defining or looking specifically at how each of them works. So an abstract class extends. Always think of extends when you think of abstract classes. You have no restrictions to your variables. The constructors are invoked by subclasses through constructor chaining, as you saw with inheritance and polymorphism 2 weeks ago. And you could always override them. There's no restrictions to the methods. We don't need to use them the way they were used in the superclass. We override them, so we use them the way we'd like to in the subclass. Interface, always think of the word implements when working with interfaces. By default, all the variables are defined as public static final within interfaces. That's why you saw earlier, we don't have to write public static final. It automatically is set that way with interfaces. There are no constructors with interfaces. It cannot be instantiated using the new operator. And all methods must be public abstract instance methods. So again, abstract extends. Basically, we're taking everything we need. An interface implements. We just take whatever we need to use. However, it's a good idea or practice to only create one interface at a time in order to avoid potential conflicts. Because you might have a class that implements two interfaces and they might have conflicting information. Two same constants with different values or methods with the same signature, but different return type. So for example, what is today? Like I said, somebody might want to put in a string, let's say Tuesday. Another user might want to put in 10 type of integer. Excuse me. So you might want to know when you should use one or the other. So abstract classes and interfaces obviously can both be used to copy or model features from their superclass. So you want to think about what the type of relationship is. So is a relationship where it's like a parent-child relationship? Then you just use abstract classes, like we saw 2 weeks ago with inheritance and polymorphism. A staff member is a person. But if you have a weak is a relationship, which is known as an is kind of relationship, then that might be best for interfaces. Strings and comparable. So, like you saw with abstract, apple is a fruit. Fruit's your superclass. Apple's your subclass. Who could give me another example from what we did 2 weeks ago? Didn't we have a musical instrument, guitar? That could be an interface because it's sort of kind of a relationship, but it's not necessarily a guaranteed. Like a drum could be considered a musical instrument. But it's not as strong as a relationship as staff member is a person. Or let's say staff member is a professor, as an example. So when you're setting up your class or designing your class, the first idea you want to think for is coherence. That's why I've shown you with some of these programming examples. I'll write out as a comment what I'm doing first in order to think through my head, what am I doing? You should think of it in coherent steps. Okay, I got to create my class. I got to create my method. I got to create my variables. Then you want to separate out the responsibilities. What is each thing going to do? What is the purpose of the class? What is the purpose of the method? What is the purpose of your variables? If they don't have a purpose, there's no reason to include them. The idea is that you want to reuse as much as possible. That's the point of inheritance and polymorphism. Same with abstract classes and interfaces. Okay, we've already created this class. Oh, we could use it again. We're going to use those same variables over. Okay, let's extend it if it's an abstract class. Let's implement it if it's an interface. We tend to use an abstract class if we want to use most, if not all, of whatever is in that abstract superclass. Inheritance, we're going to implement it, but we might just use some of it. So another suggestion is to provide a public no argument constructor and override it whenever you need to. You saw that with inheritance and the abstract classes 2 weeks ago, where, okay, the cat meows, the dog woofs. That was an animal abstract class. We extended it in order to change our method as we needed, depending on our type of animal. So obviously you want to follow standard Java programming style. As you've seen when I've gone through my programs during our Thursday class meetings, I try to be as specific as possible. And sometimes that creates issues. You know, you've seen I make some spelling errors here and there. So I think it was Amelia. She tends to use this where let's make it as simple as possible. You know, if it's a circle, let's do circle C. Right, Amelia?
Yeah, I always try to make it very simple. Even I'll even say circ or something because that's not that many letters. I can just go CIRC, CIRC, and then capital C. I just base simplicity so you can't make that many mistakes.
So either way is perfectly fine. And in some ways, that way is probably better because you're not going to make as many spelling errors. You're not going to, oh, okay, I got to go back and fix this. And especially when you're creating your class names. So like mine have been like, oh yeah, class Bob Seeks Joe, something like that. Whereas you might be able to just create your class name as, BSB or something much simpler. And again, that's why using comments to remind yourself, okay, this is what I'm doing. Okay, this is what I'm doing here is another good suggestion. But as I mentioned, unless I specifically ask, like I did last week with the exception handling homework, you're free to use your comments as you need to. So you can use what are called visibility modifiers during your programming as well. Each class can represent or present two types of contracts, one for the users and one for the extenders. In other words, you're extending an abstract class. If somebody else is going to use it when they're extending it, you might want to have different availability for them. Think of like your personal computer, right? You have your login. That's all your settings. You can have all your availability, whatever you need to do, right? You're the lead administrator. But say you have a family member, a cousin, a little brother, whatever it may be. They might also have login capabilities on your computer. But let's say you're using BlueJ for this programming class. When they log in, they might not necessarily have access to BlueJ. You don't want them playing around with BlueJ and making some kind of issues. So you may have prevented their access to it. So they have access to most anything they might need to use on your computer, the things, you don't want them playing around with. They're not going to have access to your files, as an example. They may not need access to certain programs you use for your classes. So you extend them the possibility to log in to your computer using their own login, but you're only providing them with certain availability. They can only access certain programs. They can't access your files, etc. So think of it that way. You, as the super user on your own computer, you have access to everything. When somebody else logs in, you can make it so that they can't access your files. They can't use certain programs. That's basically what an abstract class has the possibility of doing. Okay, we extend certain things. We may hide others. So ideally, a class should use the private modifier to hide its data from direct access by clients. You can use get methods and set methods to provide users with access to the private data. Same concept. Let's say you have let's use the example of my other class. You have Android Studio loaded on your laptop. If somebody else is using your laptop, well, they have no reason to use it. They're not in that class. So once they log in, they probably don't have access to it, right? You're going to set that specific program to not be usable. You're going to set your files to not be accessible. They don't need them. They have their own space on that laptop to log in. Think of it similarly if you were to log on to a computer on campus. You each log in individually. It's not just a computer that's on and everybody has access to it and everybody's files are out in the open, right? You each have your login you can log in with, and your files are saved as needed. You can access them. The IT people probably can see what's there and have access to it. But other than that, nobody else has access to it unless you give it to them. You grant them access. And that may be why you might want to use what's called the static modifier. It allows us to share instances of a class. That's why we use public static void when we create our methods. This way, we could use them as needed. They're accessible, they're available, we can use them. In most of our examples so far, we've only had to create one kind of method. We've either done public static void string args, or a passing string as an argument, or we've just created a method to use like itself. Like I think in the animal example we did with inheritance, we created a method called speak. The dog woofs, the cat meows, etc. So again, the primary difference is that an abstract extends. We can take on anything within that abstract class. We can override, we can change, we can modify as we need to. Whereas an interface, we just implement it. We might use about 40% of this. Okay, let's implement it. Whereas an abstract class, okay, we might use 90% of it. Let's extend. Anything we need to override, we just do add override. We modify, we change as needed. Okay, so if there are no questions on that, on Thursday, we're going to do some examples of this. They'll look probably similar to what you saw a couple weeks ago. We did inheritance and polymorphism, because as I mentioned 2 weeks ago, that is when you would most commonly use abstract classes and interfaces. When you need to use something that's already somewhere else, and you could either extend it, basically copy most of it, or implement it. Use some of it, maybe a little more than some of it. The idea is with an abstract class, you're probably going to use most of it somewhere else in the subclass. An interface, you might use some of it. So the abstract class or the interface that you create is always going to be your superclass. Then your subclass would either implement as an interface or extend it as an abstract class. So are there any questions on all of that?
I looked at the name and I said, oh, that's Gabby. It's because of it, Robert, but I'm like, that's the same.
No, I think that all makes sense, Professor.
Okay, good. So if you're not sold or still aren't entirely sure, as always, I have additional links for you guys to look through and watch as you need. So on Thursday, we are going to, as I mentioned, work through a couple examples of abstract classes and interfaces. And then I'm going to show you an example that will also help you on the newest homework. Write a Java program using abstract classes interfaces to display the calendar of the month you were born. So you could either set that 2 different ways. You could have it set where you as the user would just input the information using the scanner class, or you could set it up right within your program. Okay. I was born March 2004. Display the calendar. So this is similar to what we did earlier. However, instead of just using a public class, you're going to use either an abstract class or an interface. Basically, now implement it based on what you've learned this week. All right, so if there are no questions, I will see everyone on Thursday. Enjoy this gorgeous day. It's about 70 degrees and sunny out, so go ahead and enjoy it. And I will see everyone on Thursday.
Okay, bye, Professor.
Okay, Professor.
Thanks, bye.
Oh, okay.